Algebra 2, here we go. Rational exponents. Essential question. Why are rational exponents useful? Remember, rational is just another word for fraction. Okay? So what we're doing here is taking our radical form, notice the radical symbol here, x to the m power, taking the nth root of it, and we can rewrite that as x to the m over n, where our exponent, our power, goes on top, and the root that we're taking it to goes on the bottom. Okay, so there's our fraction, our fractional exponent, rational exponent. Okay, so why is this useful? Because we're in the last section we couldn't combine some things because we didn't have the same radical roots. Now we can do it, okay, by changing them into fractional exponents and then applying some of the rules of fractions and some of these principles right here. And then we can combine them when they're not the same root. So what are some of these properties? They should look familiar to you. When you multiply common bases, you just add the exponents. If you take an exponent and you raise it to a power, you multiply the powers. If you have more than one term in here, remember that's the same as 1 times m, 1 times m. Both the a and the b have 1 for an exponent. So it becomes a to the m, b to the m. You've got to take it to both of them. If you have a negative exponent, we flip it and make it positive because we don't like negative exponents. Multiplication, we added the exponents. In division, we take the top minus the bottom. Okay, so you do the opposite there. And again, just like over here, a over b to the m power. Remember, a and b are both to the first power right there, so you're going to multiply each of them by m. You get a to the m over b to the m. Okay, and what that looks like over here, simplify some of these. 2/16 to the 1/3. That's the first power to the third root. So that's the same as writing the third root of 2/16. That's just 6. Okay, some of these you're going to get familiar with as we go. Others you'll need the calculator. Here we go, common base, add the exponents. 1/2 plus 1/2 is 1. It's just 7. You could also think of that as the square root of 7 times the square root of 7, which is the square root of 49, which is 7. Okay. You'll notice here, same powers, different bases. Okay, so in this case here, when the powers are the same, you can just multiply, or if it was division, you could divide the two numbers. So here you can multiply 5 times 125 and you get 625. Take that to the fourth root of that and you get 5. Okay, let's look at a couple more examples here. If you're converting, just like we showed here with that first property, x to the 3/7, that's the same as x to the third power, and take the 7th root of it. Another way of looking at that is sometimes you want to take the root of that, okay, and then from there, then you can raise it to the power. Okay, we'll look at some examples of that. Here, remember, square root, there's a 2 right there, we don't put it, so that's the same as a to the 5/2. Alrighty, so here's a couple of examples. Alright, in present form, you've taken different roots, so you can't do it. So we're going to rewrite these in rational form for the exponents. That's 3/4, and that's x to the 2/8. And 2/8 can be simplified to 1/4. This is division, so we subtract the top exponent minus the bottom. 3/4 minus 1/4. Remember, when you add subtract fractions, you got to have a common denominator, which we have here. This is x to the 1/2. 3 minus 1 is 2. I'll just write the whole thing out. 2/4. That's the same as x to the 1/2. And if you want to write it in radical form, it'd look like that, the square root of x. Okay, that's rational form. That's radical form. 16 to the negative 2/5, or 2.5. Okay, we said we don't like when we get negative, so we flip it and make the exponent positive. 2.5 is the same as 2.5, right? So 16 to the 2 1/2. We can make that an improper fraction. 2 times 2 plus 1. That's 1/16 to the 5/2. Now we're getting into what we're talking about here. We've got a rational exponent now. Okay. Now, how do I want to represent it? Do I want to take 16 to the 5th power and then square root it? Or do I want to square root 16 and then take it to the 5th power? That's what I'd rather do because I can take the square root of 16. That's why I would do it like that. Okay? Either way, but because I can take that square root and it's 4, now it's just 1 over 4 to the 5th power, which is 1 over 1024. Okay? So you have a little leeway there. You can go either way. All right? Negative 32 to the 4/5. 5th root, so I can do that of a negative. Okay, remember you can't take the even root of a negative, but you can when it's an odd root. So this right here is the same as the 5th root of negative 32. And here again, you're going to get used to this as you go, but I can take the 5th root of negative 32. It's negative 2. So I want to do that. I don't want to take that to the 4th power and then 5th root it. I want to do it like this. So that's negative 2 raised to the 4th power. Okay, I'm going to keep that in parentheses because it makes a difference. Okay, the 5th root is negative 2. So if I didn't put the parentheses around it, I would be taking the 4th power of 2 and then making it negative. And that's not what I want to do here. So negative 2 times negative 2 times negative 2 is 16. All right, so be aware of that. What else? Technical difficulties, they happen. Okay. Last one here. Now, this is kind of kicking it up a little bit here. Okay, but if you apply the principles that we first talked about, that 2/5 got to go to each one of these. Okay, so I've got a negative 8, I've got an x, and I'm going to rewrite this right here as xy to the 1/2. Put it in a rational form. Okay, and then all this is to the 2/3. So this is the same as first power. So I'm going to multiply the 1 times the 2/3, so I get negative 8 to the 2/3, x to the 2/3, and 1/2 times 2/3, that's 2/6. Okay? This right here, negative 8, that's the 3rd root of it, right? And I can take the 3rd root of it, so I'm going to write it like that, because the 3rd root is negative 2. X to the 2/3 is going to stay that way. Remember, these are each 1. And 2/6 is the same as 1/3. Okay? So I'm going to get x to the 1 times 1/3, y 1 times 1/3. I can take the cube root of negative 8, it's negative 2. Negative 2 squared is going to be 4. Again, I want to put parentheses around that. I can add exponents here on common basis, so I'm going to get x, y to the 1/3, so I get 4x, y to the 1/3. And that's in rational form. Okay? This can be more complicated if you try to do too many steps at one time, but I just try to take everything one thing at a time, break it down piece by piece, okay? So we get the correct answer. That's what we want to do. I'm not looking to shortcut steps and get confused and forget fractions and all that kind of stuff. So write it all out. Okay, it didn't take long to do that. But do everything piece by piece, just applying the principles and properties that we started with. Okay, so that's rational exponents. We'll look more at that in class and look at some application of that. All right, we'll see you tomorrow. Bye.